Hello, my name is Tom Asano, and today is February 12th, 2024. In this video, I'm going to be talking about the Dell Power Calculator. Okay, once you're in the tool, you need to have a site. So you go to site. If you haven't created one already, you can add one. My default is USA, and this one site will handle both single phase and three phase. But to create a site, just click Add Site, give it a name, then pick your region or country, and that's it. It automatically picked Delta, which is typical for the United States, the voltage that it uses for single phase and three phase, and then some estimates on utility rates and emission factors. Click Submit, and you create the site. Okay, now that I've created a site, I'm going to say I want a new system. We give this system a name. I'll call it Demo 1. Now, this is the ambient operating temperature of the data center. So below 26C is about 78.8 degrees Fahrenheit, which I would say the typical data center. 26C to 35C is 78 to 95, and above 35C is above 95 degrees Fahrenheit, which I would call a hot data center. Some people like to choose the hot data center. I like to choose the typical data center. Now, the operating mode is the maximum is the average maximum power under normal workload. Recharge is not relevant to us because that's for if you have like a battery backup or UPS in the rack and those batteries are charging, they're recharging. The next one relevant to us would be 100% workload, which means it's the average max workload under the worst case workload. So that's one that I typically select. The site name is going to use the power that we just created, the USA, and I've been doing a lot of single phase work, so I'm going to pick single phase. Okay, now we go to rack. So a lot of these menus are going to be dependent upon the selection you make prior. So here I'm going to select a product. I'm going to say power scale. And now that I selected power scale, I pick the rack that I want, which I'm going to pick the Titan S, which is the latest rack we should use for power scale. And I click add, and it adds the rack over here. Now we need to add elements to the rack. So we click element. Again, power scale is selected. So this is where it can get a little confusing. The category, so if I pick category in power scale, I can say storage node, and then under elements, it'll show me the power scale nodes that are available. If I pick storage processor, it'll show me the latest gen of the isolons. If I go to isolon and I select these, I'm going for a storage processor. I'll see all of the isolon chassis available, and I select category, which would be storage processor, then elements. I get to see all the previous gen isolons that are out there. Also, this is where you're going to pick your switches from. So if we go to switch, and you'll see the switches, there isn't the 5232 isn't listed here, but so I usually just pick the Z9100. It's a 32 port 100 gig switch, so that should work. Okay, so let's start adding these to the rack. I'm going to pick an F900. I'm going to add 6 of them, highlight the rack, add, and I got my 6 F900s in there. Now I also want to add some F810s, so I'm going to go back to Isilon. I'm going to pick my storage processors. I'm going to pick some F810s. I'm going to say add. You can also drag and drop. So I could just, it's kind of weird when you do this. If you look as I move this, you'll see it highlighting slots with blue. That's where it's going to drop it. So you have to kind of be a little strategic in how you're dropping them. Okay, so I got those added in. Now I need to add the switches, my switch, my wannabe 5232s. I can put them up here. Okay, so now I've added all the elements to my rack. Now if you notice, there's red dots in the FA10s, which means they are not completely configured. So we have to double click on the FA10s. We have to select how many nodes are in this chassis, right? So we're going to pick the F810s. It's going to have 4 nodes. We can pick the front end. We'll do 10 gig. And we can do the back end to the 40s. And what drives do we have in? We can pick the 15 with the 12 gig flash. And we could say it's fully populated. So we say 120 of these. So we click save, and it gives us the environmentals for that. And now you can see that the dot is green. So another way to do this, you could just click this and say duplicate, and then you would duplicate these, right? So I could probably just delete this one, delete this one, delete this one, and I could just duplicate these and drop this where I want it. Duplicate, duplicate, come on. Okay, so now they're all green dotted. So now this configuration is complete. So as you click on these, now you'll get a more representation of the environmentals on the right. So for the F810 with 4 nodes, here's the environmentals for that. The switches, here it is for the single switch. For the F900, here it is for the F900. Now at this point, if you were just looking for the environmentals, you'd pretty much be fine. You could see them over here. If you click summary, it'll also give you the weight down here. So you could click finish and it would give you a nice summary page with the elevations. But if you need to figure out the whips or chords you need, then you might want to add the PDUs. So when we configure the Isilon or power scale in the DSC, we can select which rack we want, but we're not given a choice on what generation PDU we get with it. That's automatically installed into the rack, the appropriate PDU. I was given this chart that I can share. So when we install a power scale or Isilon, except for the 3000, 7000 into a Titan S, they're going to install a Gen 3 PDU. If it's the ECS EX5000 in the Titan S, they're going to install a Gen 4 PDU, and so on and so forth down here. Now, the differences between the PDUs, I mean, there are single phase and 3-phase PDUs, but the differences are the number of outlets, so or receptacles. So the number of outlets in a G3 is that it has 37 C13 outlets. Now the G4, I was told the EX5000 is the biggest power consumer that we have. So that requires C19 plugs. So the G4 PDU has 16 C19 plugs and it has 5 C13 plugs. So the 13s are for the switches, right? So that's why we have 2 different PDUs. This has all C13s. This has mostly C19s and a couple of C13s. Now the G2 is that's got 28 C13s in there, right? So now depending on how we jumper the the PDU determines how many chords that we have per PDU. Configure how many chords we want. We need to understand the concept of branches or the circuit breakers, some people call zones, for the PDUs. So here is the top couple branches of the PDU that I have. So as you can see, I have 4 outlets here and they are associated with this circuit breaker and they call that a branch. So you can see this is CB12, circuit breaker 12, but it's called branch 12 in the configurator. So each of these are broken into different branches, right? Some people call them zones. So this circuit breaker is about 16 amps in a single phase. So what you'll have is you can have 4 nodes in here and they can't consume more than, I would say, 15 amps because 16 amps is where this is probably going to trip. Now, you have to keep in mind, and the configurator is going to help you with this, but If you have a node that is consuming 10 amps of power, has two power supplies in it, and each power supply is plugged into a different PDU. So that node is plugged into the left PDU and it's plugged into the right PDU. So that entire node is consuming 10 amps total, but only 5 amps from the left and 5 amps from the right. Now, what happens if a power supply fails or the PDU fails? What that node will do is push all that current to the remaining power supply or PDU. So in this case, you would really want, if this was 16 amp breaker, let's say I only want 7 amps here in a normal state, because if the other side fails, it's going to get doubled, so it'll go up to 15. Now, Power Calculator will help you with all that, but it's just a concept that I want you to understand. Now, another concept I want you to understand is that these circuit breakers are kind of failure domains if you want to. So when this circuit breaker trips, it's going to take whoever's plugged in here out with them. Now, when we configure chords, the chords, we can select how many branches we want per chord. And again, so depending on how we configure it, how many chords, and in this scenario over here, this is a whole PDU, I selected 3 chords. So we can see that each chord has 4 branches or circuit breakers per chord. So now if I was to lose this entire chord, I would lose these 4 circuit breakers. So when I start plugging in my nodes, I want to distribute them as evenly as possible across all these chords and all these branches. So in an animation I'm going to show you is that the first node is going to plug into the first chord. Second node is going to plug into the second chord. Third node will plug into the third chord. And then when I start the fourth node, it's going to go into the next branch circuit. And then I'm going to keep doing that. So then the fifth one's going to go into this guy's branch circuit. The sixth one's going to go into this guy's branch circuit. So then what's going to happen is I'm going to separate these and move them evenly amongst all them so that depending on what fails, whether a circuit breaker trips or a chord fails, I minimize the number of nodes that are impacted. Okay, let's start the animation. So chord 1, chord 2, chord 3, the first node, second node, third node. Now different circuit breakers per chord. Third circuit breaker per chord. Fourth circuit breaker per chord. So now hopefully you can see visually that if this circuit breaker drops, I'm only going to take this node with it. If this chord drops, I'm only taking these 4 nodes with it. Now they're going to use the other PDU on the other side and shift their load over there. But the idea is that the impact is minimal. Now this is nirvana, right? If you could configure it this way, that would be awesome. But in the real world, physically, the way the nodes are racked, you may not be able to plug them in this way. You may have to buddy some of these up, right? Because the power cords are only so long. But the idea, I want you to understand the idea, right? So minimize these. Don't plug, 2 more in here. Maybe plug 1 more here and the next one in here. So we're trying to keep it as evenly as we can across the circuit breakers and the cord. So that's the concept I want you to understand. Okay, now that you have the concept on how to hopefully evenly distribute the power amongst the PDU, let's look at the power cords. So in the Power Calculator, you'll see here by colors, these are the chords. So let me just show you that. So chord 1, chord 2, there are greens, blues. These are the chords. So down here at the bottom, we can turn these switches on and off here. They're really jumpers in the configurator. And based on how we turn these on is how many power cords we have. So right now we don't have any jumpers or any of these switched. So we have the max chords, 6 chords. So I'm using this as the worst case scenario. But we can, in the configurator, I'll show you how we can use these jumpers or switches. But I wanted to show you, when you're looking at the configurator, these are the colors. So this chord, this 2 breakers, they're both on chord 1. These 2 branches or breakers, they're on chord 2, and so on and so forth. Now you can see over here, that this F900, these 2 F900s are on this power chord. So you could say, if I was to lose this power chord, I would potentially lose the power to the one of the power supplies of each of these F900s. So you could kind of see the impact if you were to lose this. Now also you'll notice, and we'll see this in the configurator, how many amps we're pulling here, and I'll get into that. Now you'll see these charts, single zone versus dual zone. So since we're using mirrored PDUs, meaning a PDU on the left and a PDU on the right, it is assumed in a normal operating condition that line cord 1 is going to be pulling 4 amps. So we can look at this line, the yellow cord, line 1, so that's pulling 4 amps. So we could say, yep, this circuit breaker or branch 1 is pulling 2 amps here, and this branch, circuit breaker 2, is pulling 2 amps, so that's 4 amps. So that's where this cord as a total is pulling 4 amps in a dual zone configuration. Now, what if I lost the cord on the left side on the other PDU, or the breaker on the other PDU tripped, or both breakers would have to trip? What would happen? So this potentially, this cord would pick up that whole workload if the other cord on the left side failed, and that would bring up the single cord number to 8 amps. So now we know in a a failure state, this line cord could potentially handle 8 or carry 8 amps. Now we don't want to overload the cords, we don't want to overload the breakers, and that's where the calculator comes in. It protects you from all that. If you start plugging these in incorrectly, it'll give you the warnings there that, hey, you're going over the single cord number. So yeah, you might be okay down here in the dual cord amperage, but if you went into a single cord or a failure state, you will exceed what that cord can carry, and you'll get a warning. So we'll see that in the configurator. So I wanted to show you the concepts. So these colors are the cords. There are breakers or zones associated with each cord, and you can see these are color coordinated. PDU1A, they're all PDU1A is one side, B is the other side. This is 16, which means it is plug number 16. So we can go up here, and here's 16 right here. So that guy is 2 amps here, and that breaker has a total of 2 amps because he's the only guy plugged in. So I wanted to show you the concept of these charts over here, what a single zone was, what a dual zone was. These cords represent these cords. Now, if I let this slide build out, I'll show you the arrows of how these are kind of plugged in and equally distributed. Now, the F810s I'll show you in the configurator, they require, since it's a chassis and it has 4 nodes, it requires 2 cords. I didn't put them in here because it would just start to get too confusing with all the lines. So let's go into the configurator. Okay, so now we're back in Power Calculator. We change our work mode to PDU. Changes over here, we select, since I am using Power Scale and a Titan S rack, you can actually see down here what rack we're using, Titan S. I know that it's a Gen 3 based on my chart. We're mirroring our PDUs, which mean we have a PDU on the left side of the cabinet, a PDU on the right side, A and B. And I'm going to select the plug for the cords, and they're L630s. So now you can see on the right here, we have the PDU. If we scroll down, you can see these jumpers down here. So there would actually be a cable jumper that can be installed, and we can simulate that in the configurator by throwing these switches. So you can see that, as I showed you before, this is a cord. The yellow is cord 1. This is cord 2. As I throw this jumper, what's going to happen is it's going to include these 2 circuit breakers. So do you see how it went from these 2, and then it just added those 2? So it just jumped this guy to this guy, right? So now I have 4 branches or circuit breakers to this cord, right? So then I could do it again to the next guy. Then I put him, so now you can see I just jumpered these 2 kind of together. It's logically I did that, all right? So you could see that this created 4 branches again, right? So now I can do the last one, this guy, and you could see up here, now I put these 4 branches onto that cord. So now I have 3 cords. It's a shame that these charts don't reduce the cords here based on how you have it jumpered, but you're just going to have to look at the amperage and disregard the cords that aren't used. So we're using Yeah, it even makes it more complicated. We're using yellow and then we skip the green, we go to blue, we skip the brown, and we go to purple. So that's how it's numbering the chords. So that's how you use the jumpers down here. And you can do that in any configuration you think is needed. For me, this is the most balanced. I don't believe there was any power scale configuration where I needed more than 3 chords per side. Depending on it, if it was the higher density nodes, then I might need 4 chords per side. But Power Calculator will tell you if you start overloading it. Okay, so you might want to do um, something like this, right? So you might want to do, since the nodes get put in the bottom of the rack, maybe I want to put more chords down at the bottom and less chords up at the top because that's where the switches are going to go. You could do something like that perhaps, but it's something you're going to have to use in Configurator. Now, I was told by the team that actually assembles the PDU and the cabinet that they include all the jumpers, so you don't have to worry about them being ordered separately. Okay, so how do we actually do this? So just thinking out loud, I have 6 power scale F900s here, so I'd like to maybe put 2, no more than 2 per cable. I should be able to do that. It's going to be a little wonky up here when I get up here, but you'll see as we go through it how that works out. So I double click on this and I select the PDU, and then I'm going to pick what plug I want it to go into. So as we saw in the animation, I'm going to pick PDU1A, and it's going to be the first plug here. Pick that one, and then I'll put this guy on the same power cord, but a different breaker, right? So that's going to be up here. So it'll probably be number 4. Put them on 4. So now those 2 are on there. Now this guy, I'll want to put him on a different cord. I'm going to put him up in the blues. So I'll put him on 13. And this guy I'm going to put on the next one, which will probably be 16. And then this guy I want to put on the next cord. So I'm going to put him on 25. And this guy up here, I'm going to put him on 28. So now you could see these guys, visually through the power cords, 1 power cord, 2 power, 3 power cords. If I was to lose an entire power cord, I wouldn't lose more than 2 of these nodes, half the power. Keep remembering when I say I lose them, I'm just losing half the power to these nodes, right? So that's what would happen there. Now, the FA10s, they get a little bit more complicated. So if we look at this, it's interesting. You'll see total outlet connections will be 4. So that's going to wind up to be 2 per PDU. If we look down here, you'll see total outlets is 2, and that's 1 per PDU, right? So this guy's got 2 per, so I'm going to have to select 2. So again, I want to kind of distribute them as best I can. So I think I'm going to pick number 7. I'm going to go down here, and I'm going to go up on the blue and do 19. How's that? And then on this guy, I'll probably use that same chord. I'm going to use, let's see, I'll probably use 10 and 22, I think looks good. So you can see how, again, keeping them in different branches, there's no 2 nodes on one circuit breaker so far, right? So let's keep going. As we go up, PDU, I'm going to put this guy, I have to put him on, since I have, 4 of these, I have an even number, not an odd number, I'm going to have to load somebody up a little heavier. So I think I'll put this guy and this guy up on 31. So save. This guy I'll put on the next chord. So put him on 18 and 34. And then the switches, I'm going to put him up on 33 and 37. Okay. So now you can see visually, it looks like, we have it pretty evenly distributed here. If we were to lose a cord, what might happen. And if we were to lose a breaker, so this guy down here, this branch has two people plugged in. This guy has two plugged in, and this guy has a couple plugged in. So now you can see, how many amps we're pulling here. So this plug here is pulling 2.4 amps. The switch is only pulling half an amp, but this entire branch or circuit breaker is pulling 2.94, right? And then the same thing for this circuit breaker or branch, 2.94. This branch or circuit breaker, 2 amps. So there's 3 circuit breakers to this one cord. So if we look at this one cord, which will be cord number 5, we can see the total single is 19. So that's in a failure. If the other PDU failed, this is what he'd be at, 19. If we were in normal operating state, no failures, he would only be pulling 9 amps, right? So hopefully you can see that. The same thing down here, 2.4, 2.4. These two guys equal a total of 4.7, 2.5, 2.4. And again, the total for this branch, 22.79, 11.3 in steady state. So again, it's unfortunate that it doesn't take these cords out that aren't used, but regardless. So the other thing this chart is nice for is now you can look at how your cords are loaded. So now I can see I pretty evenly got my amperage, the current going pretty evenly amongst all these cords. So that this is a optimal configuration, right? And I'm not going to lie to you, I went through this a couple times. I didn't do this the first shot through this. It's going to take a couple times of you playing around. So let's see a different scenario. Let's see if I put, let's see if we just start loading up one of these, maybe one of the errors we'll get here. So here we go. Here's our first warning. It says the 26.4 amp current limit for the single zone on line cord has been exceeded. So that means if you were to lose the cord 1 on the other side and all that current or workload comes over this PDU, you're going to exceed this current amperage here. So there's your warning, right? So in steady state, you're fine, but in a failure state, you're in trouble. And then it'll keep doing that. So if we keep loading them up, it'll give us another warning. You've exceeded the 30 amp limit for the single zone line cord current amp is exceeded. So you're going to get these warnings. So then that's when you have to start moving things around. And as I said, it may take a couple tries for you to do it to get it to that perfect state that I showed you earlier. But hopefully you got the idea, the concepts on how to use this. Okay, so through the magic of video, I switched it back to the good configuration. And when you're done, you just click finish. And now it gives you a lot of the information here. So you want to make sure you click save and demo 1. So now I saved it. Another word of caution, these screens will time out. So don't think you can leave it and come back later on. I'm not sure what the timeout is on these. It's pretty 10, 15 minutes maybe. So don't go have lunch and come back and expect it to be there. I've had it where I've lost everything. So here's the summary. So you can say, you can use all of these. You can change to the 100% workload number, the maximum. You can get the elevation here. You can export these to Excel, PDFs, XML. So I hope you found this helpful. I hope it gave you some concepts on how to use Power Calculator a little bit more efficiently. As I said, with PowerScale and Isilon, you typically wouldn't have to go through all this, but with the ECS now moving into DSC, you need to know how many cords you're going to use. It asks you in the DSC, how many power cords do you want? Unlike PowerScale and Isilon, where it says you're getting 3 cords or you're getting 4 cords. So that's what started my journey down Power Calculator, was an ECS configuration in DSC. And when I started reaching out for help, it seemed that not everyone was familiar with it. So I thought it would be beneficial if I created this tutorial. So if you found this useful, please like the video, or if you have any questions, email me on the company email. Thank you, everyone.